All right, good morning. I was going to do this lesson live in class, and the more I thought about it, I feel like we just don't learn well that way. It's hard with only a few kids in class and people at home. It's just not, I don't think it's a great way to learn math. So instead, I'm going to put these notes online. So you might want to grab a copy of them, or you can just look at them as I go through them. Today's notes are going to be fairly easy, but I don't know that you've ever seen this kind of word problem before. The first thing you need to know is, so I'm going to call these word problems consecutive integer word problems. So the first thing you need to know is, what the heck is a consecutive integer? Well, what the heck is consecutive? So consecutive means when things come, in a row. So consecutive, let me pull this back out, sorry. Consecutive is like Monday and Tuesday are consecutive days of the week. The 4th and the 5th are consecutive numbers. Consecutive means they come one after the other, okay, numerically. So consecutive integers means no fractions. Remember back from classifying numbers, integers means no fractions. So consecutive integers would be like 2, 3, 4, and 5. There are 4 consecutive integers. Consecutive integers can be 100, 101, 102. There's 3 consecutive integers. Consecutive integers can be negative, -6. What comes next? Not -7, because I'm going to always be counting up. So -6, -5, -4, -3, and so on. So these are examples of consecutive integers. When I do these problems, I will never get a fraction for an answer because everything I get is going to be an integer. That's the one good thing about word problems, is I won't get fractions. You also need to know what consecutive odd integers are versus consecutive even integers. Well, consecutive odd would be like, if I start at 3, the next one would be 5, 7, 9, and so on. If I started at 8, the next one would be 10, 12, 14, 16 if we're talking about consecutive even integers. So that's one thing that you need to know. The other thing you need to know is how to represent consecutive integers with variables. So every single time I do a consecutive integer problem, I'm going to have to let x equal the first number, and then I'm going to have to build from that. So if we have regular consecutive integers, not even or odd, if I let x equal the first number, what could I use to represent the next number? Think about consecutive integers like 7, 8, 9, 10. How much more is the next number from the number that came before it? Well, the answer is 1. So if I take 7 and I add on 1, I get 8. How much is the number after that? How much bigger is that than this number? It's 2 more. Go to 10. How much bigger is 10 than the original number? 3 more. So to represent consecutive integers, x plus 1 is the expression I'm going to use to represent the second number. X plus 2 is the expression I'm going to use to represent the third number. X plus 3 is the expression I'm going to use to represent the fourth number, and so on, depending on how many numbers the problem asks me for. If the problem asks me for 4 consecutive integers, I'm going to use all 4 of these. If the problem asks me for only 2 consecutive integers, I don't need these. I just need the first 2. All right, also, if the problem's asking not for consecutive integers, but for consecutive even integers, so 6, 8, 10, 12, I'm still going to let x equal the first number. But how can I represent the next number? I can't say x plus 1, that would be 7. I have to say x plus 2. That's going to be the second number. How do I get from x to the third number? I add 4. How do I get from x to the fourth number? I add 6. And so on and so on and so on. So if my problem wants 4 consecutive even integers, I'm using these 4 variable expressions to represent that. If it wants 3, I'm only using the first 3. If it wants 2, I'm only using the first 2. Well, guess what? Odd works the same way. If I'm asked to find consecutive odd integers, think about it. Let's say I start at 5. And let's say I still let x equal the first number. How do I represent the next one? How many more is 7 than 5? Still 2 more. How many more than 5 is 9? Still 4 more. So consecutive odd and consecutive even require the same exact setup. Consecutive integers without being even or odd don't use x plus 2, x plus 4. They go to x, x plus 1, x plus 2. So that's what you're going to see here in the notes. You could always refer back to this. For consecutive integers, x is the smallest, x plus 1, 2, 3, and so on. For consecutive evens, we go x and then x plus 2, 4, and 6, and so on, 2, 4, and 6, and so on. Okay, so you maybe read over these first problems. Let's do them. Once you get the setup done, these are super, super easy. So the first problem says, 3 consecutive integers have a sum of 39. Find the integers. Well, you could do this without algebra completely, but I want us to use algebra so that when the problems get harder and more difficult tomorrow, we know what we're doing and we're comfortable with the setup. So 3 consecutive integers have a sum of 39. That means I have 3 numbers that add up to 39. Well, I don't know what they are. So I need to use algebra. Now, like I said, you could guess and test and you can come up with these pretty easily, but let's use algebra to do it. So we're going to let x equal the first number. Well, they want 3 consecutive integers, so how do I do that? X plus 1 is going to equal the second number, and x plus 2 equals the third number. I stop there. They want 3. So these are the 3 algebraic expressions I use to represent those first 3 numbers. Well, what do I do with them? They have a sum of 39, so x and x plus 1 and x plus 2 will equal 39. This is the equation that I use. I take that equation and I solve it. So x plus x plus x is 3x. 1 plus 2 is 3, equals 39. Go ahead and solve that. The number I get for x is the first number. What are the rest of them? The first number is 12. The next one is 1 more. The next one is 2 more than 12. 12 plus 2, 14. There we go. 3 numbers whose sum is 39 and they're consecutive. You can also always check these just like you could check the other ones. Add these up. 12 plus 13, that makes 25. Plus another 14 is 39. Boom. Okay, those numbers add up to 39. So that's it. We're going to read what kind of numbers are we being asked for, consecutive or consecutive even or odd, and then we'll set it up differently. And these are just going to say, find the sum of them is some number. So we're going to add them all up and set them equal to that number. So here we go with an even one. 3 consecutive even integers have a sum of 72. Find the integers. Well, we're going to let x equal the first number. These are even, so x plus 2 is going to equal the second number. X plus 4 is going to equal the third number. And should I keep going? No, it said 3. So I just need the first, second, and third numbers. Those are what I'm going to use for my expressions, my algebraic representations of the 3 numbers. And they have a sum of 72. So x plus 2 plus x plus 4 is going to equal 72. Again, the first number, the second number, and the third number add up to 72. Once I get that equation set up, now it's super easy. So if that seems confusing, pause it, go back and watch that again. You just need to hear it sometimes a couple of times before it sinks in. Now I solve it. 3x plus 6 equals 72. 3x equals 66. X equals 22. Good. My answer is an even number, and that's what the problem wanted in the first place. So what are the numbers? 22. 2 more than that, and 4 more than 22. There we go. 3 consecutive even integers whose sum is 72, and you can check. 22 plus 24 plus 26 is 72. Beautiful. Let's just try number 3, because this has a negative. The sum is a negative number, which some people get a little wonky with. Okay, now we have 4 consecutive odds. If you want to pause this and try it and come back, that's not a bad idea. So we've got odd numbers, so we start with x. We always start with x. And whether we're even or odd, we always add 2 next. It seems a little counterintuitive to add 2 when the problem says odd. But remember, odd numbers are also 2 apart from each other, just like evens. So that's why we use the 2 again. Can I stop here? No, it wants 4 consecutive even integers. So here I've got my 4. Their sum is negative 48. So this one plus the next one. All right, here I come. Hold on one second. Plus the next one is negative 48. 4x, can you close the door? Plus 12 equals negative 48. I wasn't going to. Sorry, my mom's here to try to visit me. I get x equals negative 15, so the answer is negative 15. And then what comes next? Not negative 17, negative 13, negative 11. Okay, go try the assignment, and I hope that this seems fairly easy today.